There's a couple rules I want to review before I look into the work today. I want to review rules of exponents. Let's say I had something like x to the seventh times x to the third divided by x to the fourth. First of all, multiplication. I'm just looking on the top of my fraction. Multiplication, same base, I just add the exponents. That's x to the 10th over x to the fourth. Multiplication, we add the exponents. Now division, we subtract, starting from the top. 10 minus 4. So I'm going to call this x to the 6th. Multiplication, we add the exponents. Division, we subtract, starting from the top. Another rule I want to review is negative exponents. What if I had something like x to the third, y to the negative 5? I'm going to write that as x to the third over y to the fifth. Right? The negative exponent, it just brings the number or the letter to the bottom. I'm reviewing with letters, but technically can be done with numbers. As an example, 3 to the seventh times 3 to the third over 3 to the fourth. Notice I just changed the x for 3. That is 3 to the sixth. Now, what if I gave you guys, now to review negative exponents with numbers. I know 3 to the fourth is 81. However, 3 to the negative fourth should be 1 over 81. Right? The negative exponent brought the 81 to the bottom. Let's see real quick. 3 to the negative 2. I know 3 to the 2 is 8. It's 9. So 3 to the negative 2 is 1 over 9. Negative exponents are going to make fractions. All right, let's take a look at a couple of examples. Let me take a look at 4 examples. I want to make sure I write everything in terms of the same base. I see that I'm going to use a base 2. So to begin with, I'm thinking 2 to the something is equal to 64. I got to think of a number. Amount of times I'm going to multiply 2 to make it 64, and that is 2 to the 6. I know 2 to the 6 is 64. That means that 2 to the negative 6 is 1 over 64. All right, let me review that. So I can write 1 over 64 as 2 to the something. Right, so let me rewrite this as 2 to the p times 2 to the negative 6 is equal to 2 to the 2p. I just wrote everything in terms of the same base. Reviewing the multiplication, I know I have to add the bases. So I have 2 to the p minus 6 is equal to 2 to the 2p. Now that I have the same base, and I only have one term on each side, now that I have the same base, let me ignore the bases and let me just go p minus 6 is equal to 2p. The rest, just solve it as simple algebra. Let me subtract the p from each side. I get that negative 6 is equal to 1p. Done. Looking at question number 2, I have 5 to the negative 3n. It's equal to 5 to the 0. I wrote everything in terms of the same base. Anything to the 0 is 1. Now that I have the same base, I'm just going to ignore the bases, and I'm going to let the exponents equal each other. So negative 3n is equal to 0. Divide both sides by negative 3. And in this case, it's 0. Everything in terms of the same base. Let's take a look at this example. 2 to the negative 2 is 1/4. However, 2 to the negative 4th is 1 over 16th. Let me rewrite everything in terms of the same base. I have 2 to the negative 2 times to the p is equal to 2 to the negative 4 times to the p plus 2, and this is equal to 2 to the negative 4. I wrote everything in terms of base 2. When I have parentheses and I have exponents, I have to multiply them. So I have 2 to the negative 2p times 2 to the negative 4p minus 8. I multiply those, and this is equal to 2 to the negative 4. Reviewing multiplication, I have to add those. So I'm just going to call that 2 to the negative 6p minus 8 is equal to 2 to the negative 4. Now that I have the same base, I'm just going to let the exponents equal each other. Negative 6p minus 8 is equal to negative 4. Let me add 8 to both sides. Negative 6p is equal to 4. Let me divide by negative 6. Positive divided by negative is negative. 4 over 6, at least simplify that. I'm going to call that 2 over 3. Now let's take a look at this other example. I have everything in terms of the same base already, so that's good. Multiplication, I have to add the exponents. So that gives me negative 4x minus 3. I added my exponents. It's equal to 4 to the negative x plus 2. Now that I have the same base, I'm going to let my exponents equal each other. Negative 4x minus 3 is equal to negative x plus 2. Let me add an x. Let me add 3. I have that negative 3x is equal to 5. Divide by negative 3. Positive divided by negative, it's still a negative. I'm bringing the negative to the front of the fraction. 5 over 3, I'm just going to call that 5 over 3.